In this chapter, we'll be going over matrix properties and operations. So we're not going to be going over every type of operation there are with matrices, but we will be going over a couple of the basic ones: addition, subtraction, and multiplication. So starting here with matrix addition. So the sum of two matrices that are both m by n matrices, A and B, is also going to be an m by n matrix, A plus B, in which each element is the sum of the corresponding elements of A and B. And only matrices with the same dimension can be added. Okay, so this is relatively simple. If we want to find each sum here, we have the square matrix on the left plus the square matrix on the right. So they're the same dimension, so we can add them up. So what we're going to do is we're going to be adding essentially position by position. So it's going to be 5 plus -4 for the upper left, and then -6 plus 6 for the upper right, and 8 plus 8 for the bottom left, and 9 plus -3 for the bottom right. So just position by position for the new position. So that's going to give us the matrix 1, 0, 16, and 6. Okay, so just as simple as that. So let's do one more here. So if we want to find A plus B, and we have A is this 2 by 2 matrix, and B is the 2 by 3 matrix, and we want to add them up, we actually cannot add these because they do not have the same dimensions. So that's all we can say for that one, and we can't do anything to it. Okay, and then for matrix subtraction, so the difference of two m by n matrices A and B is also an m by n matrix, A minus B. It's the same exact concept as what we just did with adding, except now we're going to be subtracting the elements. And once again, only matrices with the same dimension can be subtracted. So for example, let's find each difference. So we have this 2 by 2 matrix minus this other 2 by 2 matrix. So these are the same dimensions, so we can go ahead and subtract them. So I'll just do this one in one step here. So it's 5 minus -3 for the first one, which is +8. And then we have the -6 minus 2, which is -8. And then we have 2 minus 5, -3, and 4 minus -8, which is 12. Okay, so once again, as simple as that. And let's do one more for subtracting. We want to find A plus B, where A is this 1 by 3 matrix. It is a row matrix. And B is also this 1 by 3 matrix. So it's another row matrix. Same dimensions, we can add these up. So this is going to be 8 plus 3 for the first one, so 11. 6 plus 5, so also 11. And then -4 plus -8, which is -12. Okay, so that was addition. So let's actually do the same question, but switch it to subtraction now. So all I did was change right here to A minus B. So if we're doing A minus B, we just switch the sign in the middle to subtraction. So it's going to be 8 minus 3, which is 5. 6 minus 5, which is 1. -4 minus -8, which is +4. Okay, so just position by position, we were able to do that one because they were both the same dimension. Okay, next thing, once again, this is relatively simple compared to what we will be doing in a second. It is multiplication of a matrix by a scalar. So a scalar is essentially just a real number. And when we multiply real numbers, we're going to call it k. When we multiply a scalar k and a matrix, it's going to be the new matrix Ka. So all we have to do here is multiply each element in A by that number k. So let's do these examples here. So we have 5 times that 2 by 2 matrix. So all we have to do is multiply every element in the matrix by 5. So it's going to be 5 times 2 is 10, 5 times negative 3, negative 15. 5 times 0 is 0, and 5 times 4 is 20. Okay, so just multiply everything by that scalar out front. And next one, we have 3/4 times 20, or 3/4 times that 2 by 2 matrix, and 20 is in the top left. So we'll multiply every element by 3/4. 3/4 times 20 is going to give us 15. 36 times 3/4 is going to give us 27. 12 times 3/4 is going to give us 9. And negative 16 times 3/4 gives us negative 12. Okay, so notice what we've done so far. The dimension of the matrix stays exactly the same. So adding, subtracting, multiplying by a scalar are relatively simple. So now on to the more difficult operation here is matrix multiplication. So we're going to be multiplying matrices, and we're going to be calling the product AB if the matrix, one matrix is A, the other matrix is B. So the product of an M by N matrix A and an N by K matrix B is going to be an M by K matrix, and we're going to find it with these steps as follows. So before we do that, just notice these dimensions here, which we'll come back to in a second. These values, which once again we'll mention in a second, the column in the matrix on the left has to be the same as the row as the matrix on the right, and the new matrix M by K that it's the product after we multiply them is going to be the rows of matrix A and the column of matrix B. So the inside numbers have to match, which they do, they're both N, and the outside numbers give us the dimensions of the new matrix that we're forming. Okay, so we'll go over these steps here. They're going to be really confusing until we actually do an example. To find the ith row, jth column element of AB, so I just represents a number, J just represents a number, depending on what element we're looking for in the product. So to find the ith row, jth element of the product, we multiply each element in the ith row of A by the corresponding element in the jth column of B. So we're going to be multiplying the rows of the left matrix times the column of the right matrix. We're then going to add up all of these products, individual products, and the sum of these products gives us that element for row I, column J of AB. Once again, probably pretty confusing without an example yet, but we'll get to that in a second. And I just put a note here. The product AB can only be found if the number of columns of A is the same as the number of rows of B, and the final product will have as many rows as A and as many columns as B, which we mentioned up at the top. Okay, so let's do this example before we get into actually calculating these products. So let's say matrix A has a dimension 2 by 2 and matrix B has a dimension 2 by 4. We want to know, can AB be calculated? And if so, what's the dimension of the product? And then secondly, we want to know, can BA be calculated? So for the product AB, we have matrix A on the left, matrix B on the right, and that does matter. We'll see why in a second. So matrix A is 2 by 2, and matrix B is 2 by 4. So this is the best way to do this when you're setting up a problem, is just write it just like this. And then you're going to check to make sure that these values are the same in the middle. So since they are the same, they're both a 2, that means we can calculate AB. And then these numbers on the outsides are going to represent the dimension of AB. So the dimension of AB is going to be a 2 by 4 matrix. And let's see if we can do this for BA. So if we're trying to calculate the product B times A, this time we have matrix B on the left because it's first in the product, and then matrix A on the right. So matrix B was 2 by 4, and matrix A is 2 by 2. So in order to be able to calculate this product here, these values would have to match. This time they are not equal. Matrix B has a 4, matrix A has a 2. So since they are not equal, we actually cannot multiply these. Okay, so just because we can multiply A times B does not mean we can multiply B times A. And if you remember back to multiplying numbers, this is the commutative property. So matrix multiplication is not commutative. We'll come back to that in a second. Okay, so let's do an example here. Let's find the product of AB with these two matrices. We have matrix A, which is 2 by 3, and matrix B, which is 3 by 2. So what I'm going to do here is I'm going to rewrite it and say the product AB is going to equal the matrices right next to each other like this. So if they're written next to each other, it's implied that they're being multiplied. And before we get ahead of ourselves, let's make sure that they can be multiplied. So we have matrix A 2 by 3. We have matrix B 3 by 2. And these numbers in the middle are equal. So that means they can be multiplied. And the outside numbers together are going to be the dimensions of AB, which will result in a 2 by 2 matrix. So in my opinion, what the best thing to do right now is get an answer matrix set up. So our answer is going to be right here. We know it's going to be a 2 by 2 matrix. So we're going to have a spot right here. So I'll put a little blank, a spot here, a spot here, and a spot here. So we have to multiply the columns of the matrix on the right with the rows of the matrix on the left, add them up, and that'll give us these 4 values. Okay, so let's do that work down here. Okay, so the way how I'm going to write this, I'm going to say we are finding row 1, column 1. So I'm just going to use R for row, C for column. We have 4 things in our answer, right? We have row 1, column 1, row 2. I'll write them out here. Row 1, column 1, row 2, or row 1, column 2. And then we have row 2, column 2, column 1, sorry, and then row 2, column 2. There we go. So we have those 4 options, so let's find them all individually. So what we're going to be doing here is we are going to be finding for row 1, column 1, we're going to be multiplying the elements in matrix A's row times the elements in columns B column, and then add those together. So the way I like to do it is think of it like this. It helps when you kind of have a highlighter and I can erase it like this. We have the column B, column 1 times row 1. We're going to multiply corresponding elements. So the way that you kind of can think about it is taking the column and laying it flat, rotating it flat on top of the row. So it's going to be -3 times -6. So the first element product plus the second element's products, 4 times 2, plus the last one, 2 times 3. And what we end up getting is 32. And let me just move all this down a little bit. Okay, and I will start a new answer matrix here, just so I don't have to erase the row 1, column 1, and everything I wrote above it. So that is going to be our first entry, row 1, column 1. So now we need 3 more. So let's do row 1, column 2. So finding row 1, column 2, we have row 1 for A, column 2 now for B, and we do the same thing. We're going to multiply the corresponding elements and add them up. So it's going to be, zoom out a little bit, it's going to be negative 3 times 4 plus 4 times 3 plus 2 times negative 2. And this will get us a value of negative 4. So that's going to be row 1, column 2. That's negative 4. And next, let's do row 2, column 1. So taking a look up at the matrices, it's now going to be row 2 for A, column 1 for B. And we do the same thing. And we end up getting negative 18. So that's going to go right here. And one more, we need row 2, column 2. So taking a look up at the matrix, row 2 for A, column 2 for B. So let's multiply these together and add them up. And that will give us a value of 12. And that goes in the spot in row 2, column 2. And that is our answer. This 2 by 2 matrix right here is our product. So now let's try to find the product of BA. So same 2 matrices here. So let's set this up. So B times A this time. So make sure that you have B written first, which we do. So let's take a look at the dimensions. So B is a 3 by 2 matrix, and A is a 2 by 3 matrix. So let's see if we can multiply them. So these 2 middle ones are equal, so we can multiply them. And the outside ones tell us the dimension of BA. And BA is going to be a 3 by 3 matrix. So what I'm going to do right away is create this answer matrix over here to help us. So it's going to be 3 rows and 3 columns. So we need to figure out what all of those values are. So we're going to multiply the columns of A, because that's the one on the right, with the rows of B, because that's on the left, and we're going to add them together just like before. So let me just fill in over here on this blank one, let me fill in the column and row number for each one. Okay, we have row 1 through 3 and columns 1 through 3 and all of the combinations of them. And let's write those down separately and find them down here. So let's do row 1, column 1. So that's going to be multiplying columns of A, column 1 of A with row 1 of B. So that's going to give us negative 6 times negative 3 plus 4 times 5. And that will give us 38. So once again, let me just move this down a little bit. Okay, and then that'll give me room to have this answer matrix, or answer over here. So it's going to be 38 in row 1, column 1. And I'll do about 3 more, and then I'll pause it and just fill in the other ones. So next we want row 1, column 2. So that's going to be row 1, and now it's going to be this column that we multiply. So it's going to give us negative 6 times 4 plus 4 times 0, which will give us a value of negative 24 for our next element. So that's going to be this one right next to it, negative 24. And let's do one more, and then I'll fill in the other one. So the next one's going to be, we'll do row 1, column 3. So that'll be that column, a third column for A, and then we're going to multiply those. We're going to end up getting -6 times 2 plus 4 times 4. And that'll give us -12 plus 16, so that one gives us 4. Okay, so that's going to be right here. That'll be a 4 over in row 1, column 3. So for the next ones, what we would do the same thing that we just did, except do row 2, column 1, row 2, column 2, row 2, column 3, and then row 3, column 1, row 3, column 2, and row 3, column 3. And do it the same way we just did all those and fill them in. So I'm just going to put and so on. And I'll go ahead and fill these in. And we get that 3 by 3 product for B times A. So what we mentioned before and what I wrote down here at the bottom of the page, well, first I recommend that making sure you try this on your own, the and so on portion down here. Make sure you can fill in those other ones on your own. Notice that AB and BA were not the same from this example to the previous one. We had the same matrices, but A times B did not equal B times A. And that's because, like we mentioned, matrix multiplication is not commutative, and sometimes one of the products may be defined. We may be able to calculate one of the products while we can't even calculate the other one. Okay, so let's do one more example here. Let's find AB and BA, given that A is this 2 by 2 matrix and B is also the 2 by 2 matrix. So let's do AB first. So we have AB, so I set them up next to each other being multiplied, and A is 2 by 2 like we said, and so is B. So the two middle numbers are equal, so they can be multiplied, and the dimension of AB is also going to be 2 by 2. So when multiplying square matrices that are the same exact dimension, they will always be able to be multiplied, and the product dimension will be the same as the matrices themselves. Okay, so we know it's going to be 2 by 2, so it's going to be 4 different values we need to find. We need to find row 1, column 1, row 1, column 2, and row 2, column 1, row 2, column 2. Okay, so let's do this right down here. So row 1, column 1 is going to be row 1, column 1, row 1 for A, column 1 for B, always the row on the left, column on the right. That's going to end up being 1 times 2 plus 3 times 10, which will give us 32. So that's going to be row 1, column 1. Next, let's do row 1, column 2. That'll be 1 times 5 plus 3 times -3. And that'll give us -4. So that's row 1, column 2. And then next for row 2, column 1, that'll be row 2, column 1, -2 times 2 plus 4 times 10. That'll give us 36. That was row 2, column 1, so that's bottom left. And lastly here we have row 2, column 2, and that's going to be -2 times 5 plus 4 times -3, which will give us -22. Okay, so those are all of our elements, and there is our product right there. So you can do once you get comfortable with them and the matrix is small enough, you can probably do some of these calculations in your head. So next for BA, I'll write these next to each other. So we have a B on the left this time, and this is going to equal our 2 by 2 matrix, like we said before when we were, when I mentioned that the square matrices being multiplied will always just be the same dimension as before. But if you wanted to double check, you would say this is 2 by 2, 2 by 2. They are in fact equal in the middle once again. And the dimensions of BA are right here on the outside. Okay, so just a quick verification. If you recognize that it's a 2 by 2 or a 3 by 3 times a 3 by 3, you don't have to do that, but it's good just to double check. Okay, so let's find the elements. Okay, so we have our 4 elements: row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So I'll just pause it and fill these in because it's the same concept as the other one. So here are our 4 elements. We have -8 and 26, and then 16 and 18 for our elements for our answer for B times A. Okay, so when you're multiplying matrices, first you have to make sure that you can multiply them. Second, you have to find the dimension of the product. And then you have to find the individual elements by multiplying the column of the matrix on the right with the row of the matrix on the left. Add up those individual products and put the element in the correct position. Okay, so that is it for this chapter.